In this section, we will be talking about estimating percentile ranks, specifically by linear interpolation. If we are dealing with a group distribution and therefore know how many scores are in each interval, but not where within each interval those scores lie, like um, we assume that one have or doesn't have an access to the raw data from which the frequency table was constructed. And basically, you can use linear interpolation to estimate both percentiles and percentile ranks. The key assumption behind linear interpolation is that the scores are spread evenly or linearly throughout the interval. So let's base our example from the previous table that we utilized. So try to go into the interval or class interval of 85 to 89, for which you could also see that there is a frequency of 8. So we could basically assume that 8 scores are spread evenly from 84.5, which is the lower real limit of the class interval 85 to 89. And you are also seeing 89.5, which is the upper real limit, as you could also observe in the example table. Now we can also assume that 4 of the scores are between 84.5 and 87, which is the midpoint of the interval. And then here, we also have 4 other scores which are between 87 and 89.5. So they are distributed evenly here in this class interval. Now, such reasoning also applies to the percentages. So if you look into the cumulative percentage at 84.5, it is about 48. Again, with a score of 84.5, we would have the CPF, or the cumulative percentage, which is about 48. And that is from the entry of 80 to 84. And also with the upper real limit of 89.5, we also have 80%, which is the cumulative percentage frequency entry for the class interval 85 to 89. Now, on the basis of our assumption of linearity, we can say that the midpoint of the interval is 87, and it should correspond to a cumulative percentage midway between 48 and 80, and which is about 64%. You could get 64 when you would be adding 48 and 80, and then you divide it into 2. So like 48 plus 80 is 128, and you divide it into 2, that is equivalent to 64. So in identifying the midpoint, basically we just got the percentile rank of the lower real limit, which is 48, and then we also got the percentile rank of the upper real limit, which is 80, and then we divided it into 2, and that's why we got 64%. And thus, if a student would be asking what is the percentile rank for a score of 87, so anybody or any student who also scored 87, the percentile rank is 64. Now, what if we are asked with a more complicated question, and that is, what is the percentile rank for a score of 86 in our example? And because 86 is not right in the middle of an interval, we need to know how far across the interval it is. Then we can use the linear interpolation to find the cumulative percentage that corresponds to that score. So to go from the lower real limit, which is 84.5, to 86, so we just actually have to subtract 86 from 86 minus 84.5, which is our lower real limit, and we would have to go about 1.5 score points, which is basically the distance between the scores. And then to go across the entire interval, we understand that from 84.5 we need about 5, a total of 5 points to go to 89.5. So 86 is 1.5 out of the 5 points across the interval, and 1.5 out of 5. So when you would be dividing 1.5 over 5, that is equal to 0.3, which is 30%. So a score of 86 is 30% of the way across the interval. And that means that to find the cumulative percentage for 86, we must go 30% of the way from 48 to 80, as we are also seeing, or if we could review the example table. So when we are reviewing the cumulative percentage frequency, so from 48 to 80, so we are reminded that from 48 to 80 there are 32 percentage points, and 30% of 32 is 9.6. So if you multiply 0.3 times 32, or let's say 30% of 32 is equal to 9.6. So we have to add 9.6 percentage points to 48 to get 57.6, which is the percentile rank for a score of 86. In sum, 86 is 30% of the way from 84.5 to 89.5. So we go 30% of the way from 48 to 80, which is 57.6. So this is actually the percentile rank of the score 86, 57.6. Always bear in mind that it is not terribly important to be exact about estimating a percentile rank from a group frequency distribution. First, the estimate is based on the assumption that scores are spread evenly throughout the interval, which may not be true. Second, the estimate may be considerably different if the class interval width or the starting score of the lowest interval changes.